This video will discuss the carryover effects of within subject designs. Within subjects designs are designs where each participant is tested under multiple conditions. So each level of your independent variable, where your independent variable is what establishes the groups that are being compared when you're doing mean comparisons in ANOVA. But within subjects designs is that every single participant is in every single level of that independent variable. And this is what the equation looks like for this type of model. Very similar to the between subjects designs, but slightly different based on the variances that are being used. These within subjects designs are also called correlated error models, but the one that you would most likely hear is repeated measures designs, or this is can also sometimes be called longitudinal ANOVA. So this goes by several different names. But regardless of the name, the biggest point is that every participant is in every level of your independent variables. So each participant is in each group. So now your ANOVA is more like a paired sample t-test than an independent sample t-test. So for the between subjects designs, you have independent groups where the participants in each group are only in one group. Whereas with now the within subjects design, it's like a paired sample t-test where we use paired sample t-test for like a pre-test, post-test comparison. And this is where every participant is in both groups. It's both in the pretest and in the post-test. But now we have 3 or more of these groups to be able to do this within subjects designs ANOVA. And so the subjects are providing multiple values for the dependent variable. And so for each level of the independent variable, each participant will have a value for the dependent variable. So the means of the dependent variable are still what's being compared across the groups, just as in any other ANOVA design. But now you have each participant is at every level of the independent variable. And so this repetition can be over time, and most often we see it over time. So it's 3 or more time points where each participant has a value of the dependent variable at each of those time points, but it could also be over treatments where it's like a leveling or a stacking of treatments, or it could be something where it's the increase of sessions, so the number of sessions, but you are measuring the dependent variable at each session. So then session 1 dependent variable value could be compared to session 3 dependent value and look and see if there's mean differences across all these different treatment levels. When we are using within subject designs, we have to keep in mind this carryover effect. Because this carryover effect is when we are thinking about how exposure to an earlier or a previous level of your independent variable can change the value of your dependent variable. So if for our within subjects designs or repeated measures designs, we're trying to look at every participant at every level of the independent variable, if there's any possibility that being exposed to one of the levels of the independent variable prior to another level of the independent variable could change the dependent variable value just by having them in that order, you have to keep that in mind. So a solution to this carryover effect is counterbalancing. And so counterbalancing is really making sure that you understand the sequencing of the levels, why they're in that order, and making sure that they're in the best order so that you can minimize or accommodate for these carry over effects. You have to also then keep this in mind when you are interpreting the results of your within subjects designs in making sure that you are including any potential carryover effects as part of your interpretation of those results.